Thanks for joining us here today. So join me in welcoming Georgios to the NIDC, and he's going to be talking to us about detecting fraud in the insurance sector. So let's hear it for Georgios.
Thank you very much. Can you hear me? Okay. Thanks for coming. It's a bit late, and I know that there's a person downstairs who's doing game development. So thank you very much for coming here to see insurance and fraud. I really appreciate it. So yeah, my name is Georgios. I'm gonna talk to you about how we can detect fraud in the insurance sector, and we actually built an in-house tool for an American insurance company that can do that. So what is today's talk? It's not a sales pitch. We don't have a tool that we try to sell to people, not at all. The tool belongs to the customer. It's just a story of how we develop the tool. So we're gonna go in detail. And is there anyone here working in insurance? Maybe Allstate, Liberty? Cool, you can copy that if they don't have it already and say, I have an amazing idea, I want to build this, okay? So my company agreed for me to solve this. So that's all. So let's start with me. My name is Georgios. I am originally from Greece. I studied in Aristotle University of Thessaloniki. Initially, I was a civil engineer, and I did my first master's there in environmental engineering. Then I flew all the way to the United States, in Louisiana, a small town called Lake Charles, where I was a research assistant and I studied breakwater designs on the Mississippi Delta. And after that, I was like, I need to go back home, but I couldn't. And I ended up here in Belfast, in Queen's University. I did my PhD in hydrology, in particular in saltwater intrusion. And why am I a data scientist now? I used machine learning to solve some issues in hydrology, mostly computer vision and time series prediction. And then I fell in love with the tool, and the sector was booming back then. So I left academia after my PhD. I joined Allstate as a machine learning engineer. And last March 2022, I joined OpenData Belfast as a senior data scientist. So what is OpenData Belfast? Is a Belfast-based startup. It was founded back in 2021, and its goal is to provide technical expertise to a specific US-based insurance carrier that is insuring homes, specifically in a lot of East Coast states. And as you know, there's a lot of hurricanes, there's also things happening in the US, so they really need to have very good home insurance there. So as I said, I joined back in March 2022. I was the 11th engineer back then. We have around 30 people right now, and keep OpenData Belfast in mind because they're gonna be recruiting more, okay? So the company is expanding right now. Okay, fraud detection tool. Let's start with what this tool is doing. For starters, we didn't build a tool that proves that a claim is fraudulent. What we did is we created a tool that indicates that, you know what, some claims look a bit suspicious. Before we created this tool, our customer had a dedicated fraud investigation team that was manually checking specific fraud claims. An example is like during the hurricane, a tree fell into my roof, broke the roof. Now my place has flooded. I need money, okay? Something along these lines. Up until that point, up until we built the tool, the suspicious claims were referred to this fraud detection team by the desk adjusters, okay? The people who were getting the claim into the system had a series of rules. If something was broken there, they will refer it. But of course, if you do some stuff manually, you're gonna lose a lot of potentially fraudulent claims. What we did is we pretty much automated all this process. So every single new claim that's created or every claim that is modified passes through our algorithm and it gets flagged appropriately. So our tool has three main components: an entity resolution module, an automated rules engine, and what we call social network analysis. So when it comes to entity resolution, as you might think, in the real world, a lot of data sets are messy. This was also the case with a lot of the data sets for this insurance carrier. We had people saved in the system with different variations of their names, and we weren't sure if it's the same person or a different person. We had people in the United States changing their names after getting married, so it appeared as two entities. Also, we had companies that changed their names or changed the addresses, and all this created a little bit of a mess. So the first thing that our tool had to do was identify who is who, pretty much. Here, I'm gonna show you an example. In the first table, we have a guy called Georgios Etsias and the second guy called Georgios Etsias. That's my name, actually. So it's two variations of the same name. In the middle, we have Mary Wallace and Mary Black. And on the bottom, we have someone called, like a company called Roofers LLC and another company called New Roofers Limited. Our entity resolution tool has around 20 data points. So by making specific comparisons, it can understand right now that, these two guys is one guy, is Georgios. Mary Wallace changed her name to Mary Black after she got married. And Roofers Limited and Roofers LLC, it's the exact same person because they have the same address and the same city and everything. Okay, so this was very important for us to know who is who, because a lot of the times fraudulent actors specifically change their company names or get new addresses or do stuff like that to get out of the system. In the end, I'll present in detail how this algorithm works. So the second component is our automated rules engine. So pretty much what this thing is doing is this fraud detection team was manually checking claims for some characteristics. Let's say, for instance, I bought a policy with my insurance provider today, and 3 days from now I say, oh, my whole place has been burned to the ground. Does it mean I'm doing fraud? Obviously not. But it's a bit suspicious because it happened just 3 days after you bought the insurance package. So there's a series of rules that these people were manually checking, and we pretty much automated this. I cannot tell you exactly what it is. This is company secret, but it's not rocket science. Finally, we have social network analysis. The thing is, in fraud, a lot of the times we have something that's called a fraud ring. Okay, there is some roofer who has done fraud in the past and sees a customer and say, oh, there's a tiny damage here. I can fix it for £1,000, but let's go claim 20,000 USD and we're gonna share the difference, something along these lines. And also there has been like fraud rings where lawyers go with contractors and they try to make more money off of the insurance companies. So the idea for us was to be able to study relationships between different parties in claims, so we can identify rings like that. So here we have an example. This is a claim, and you can see there are specific parties involved in the claim. We have the name insured, that's the customer. We have a roofer, an attorney, and an adjuster. Okay. There is a thing in the United States, there's a big database created by all the insurance providers that's called the National Insurance Crime Bureau. And in there, every single party that has been proven to be involved in some kind of fraud is saved, okay? And insurance companies can actually see if some of these people, the potential fraudulent people, have been involved in their claims. So what the tool does right now, let's say we have an indication that this roofer has been involved in some kind of fraud in the past, okay? The tool will automatically flag this claim and every other claim that this potential fraudulent roofer has been involved in and assign it a fraud score. And then, because this roofer and the attorney have been together in 4 more claims, it will also flag these claims as well. And finally, we have another roofing company that our entity resolution tool from before identified as pretty much being the same company with different names. So we flag this as well. So by studying relationships like that, based around potentially fraudulent actors, we are able to flag a lot of claims that until recently might be flowing under the radar. So finally, there's a fraud scoring system, which pretty much for its claim combines the rules broken, okay, the rules that the investigators check for, and each rule has a specific fraud score that we decide with the customer, plus the relationships, the potential relationships with these bad actors. And on a daily basis, we have an amount of new claims that are flagged as potentially fraudulent. The idea is that this will help the people investigate the fraud to focus, okay? And the tool has the fraud scores, and specifically you can go and say, we believe this is fraudulent for A, B, C, D. It broke 5 rules, and it's 5 potentially fraudulent actors, all of them involved in there, okay? So you may want to look at it. So that's the general idea. I will present now the tech stack that we built, all the main components. I'm gonna give a short definition here, okay? The tool is data science ML application. So NLP stands for natural language processing. It's when you process words pretty much, and we use it here. We're using something called transformers. Transformers is a specific architecture of neural networks, which pretty much open the road for modern day LLMs. So the first 2 modules, entity resolution and the rules engine, are built in-house using Python, and we employ transformers from Hugging Face to make this identification of who is who in our entities. The social network analysis is built with graph databases. Okay, I don't know, some of you might have heard graph databases. Normally databases are in tabular form. You have these big tables. A graph database turns this into a graph structure, which I explain later in the presentation. And we used Neo4j, which is one of the bigger companies out there that are doing graph databases. And we actually managed to build a whole tool using their free version, okay? So there's a lot of capability there for people who want to experiment with graph databases. Finally, our tabular data are saved in a Postgre database, and in the end, there is a front end that is just a Power BI dashboard that the investigators go and check on a daily basis. Okay, so this slide shows how we brought everything together in the cloud, okay? OpenData uses AWS. It's the most common cloud provider, I think. So what we pretty much have here, we have hosted a tabular database, the Postgre one. It's an Aurora DB, okay? We have an EC2 instance that has saved, that we host a Neo4j graph database. We have our 3 main modules: the rules engine, the association fraud score, the social network analysis, and the entity resolution. And the data are uploaded on a daily basis from an AWS data lake. The whole procedure is launched once a day at night in the US using a cron job. And we have an AWS step function that calls all the modules in sequence. We have 3 buckets: a raw bucket that gets the raw data. Then we apply ETLs to process them, and have the staging bucket that makes the data ready to be fed in the 3 modules. And finally, we have the curated data, which are the final data that the user can see in the tabular and in the graph database. And all the code is wrapped around what is called an AWS Lambda functions. Okay, so nothing too complex here. We're not very troubled by latency or whatever, because we have very few users. It's a tool specific for selected team of people. So this architecture, no matter how simple it might look to a lot of, I don't know, DevOps people here, it actually works. I hope so, at least. So I'm gonna show you what is a graph database in Neo4j. So graph database is not a graph, it's actually a database that turns a table into nodes, that's like little circles like that connect with each other via edges, okay? Here we have an example of how a specific insurance claim looks in the form of a graph database. So in the center, we have the claim. Here it shows the day the claim was filed, but each node, each little circle has its own properties, nodal properties. So it's like when it was filed, how much damage was it, what's the reason behind it, so on and so forth. With pink here, we can see a policy. This is a policy node, okay? So a single policy can have multiple claims because multiple different damages happen to a house. With red is a property, okay? So we have multi-property policies. Someone owns 20 different houses, have them all under one policy. And finally, Georgios with the light blue is the customer, and the dark blue are all the parties involved, okay? We have a trusted vendor, Gibson Claims, and Etsias Construction. All of them, of course, are fake data just for the presentation. And finally, the green one is the event, a specific hurricane. So this was the first time anyone in that company was able to see their claims in this form and say, oh, wow, these are all the people involved. Because before, what they had to do is go line by line, row by row in the tabular dataset and try to understand. The good thing with the Power BI is you can ask it and say, you know what, these three people, I don't like them. Is there any other claim that these are involved? And you can get something along these lines. You can get an automatic visualization like this. And suddenly we know that in 2022, there was another claim where all these three people who could potentially be a fraud ring were involved. And you can expand this again and again, and then you can create things like that get progressively more cluttered. So these investigators can actually try and manually find patterns that our tool doesn't understand up until now. And because some of these people used to be law enforcement back in the US before coming to the insurance company, they actually love this part of the tool. And I've seen them plotting huge graphs and going like it's a crime scene. So yeah, if you want to investigate fraud, I suggest using graph databases for relationships. They actually work very well. So for the next part, I will present the in-house entity resolution tool we built, okay? And I'm gonna this is how it works, okay? The idea is we do matching, that is we compare one entity with another, okay? We go to pairs of entities. But if I had 20,000 different entities to go pair by pair, this is an exponential number of pairs. So before that, we're doing something that's called blocking, okay? Just decide the subset of entities that we're gonna compare with each other. We have two ways of doing blocking. It's token blocking and standard blocking. So it's easier to explain all that with a simple example, okay? Here we have 9 entries, okay? The first 6 of them is some variation of my name, okay? The final 3 are some colleagues from OpenData, okay? And we have birth year, email, and mobile phone. So how blocking works? We can do token blocking and we can do standard blocking. Tokens in natural language processing can be anything from a single word to a whole paragraph, okay? So we decided to go on full name token blocking word by word. So what the tool is gonna do is gonna find everyone who has the same first name, 3 George, 2 Georgios, and everyone who has the same last name, 5 people named Etsias, and we'll put them in a block, okay? And then we continue with standard blocking for the rest, and we're gonna put all the people born in 88 in another block, all the people born in 78 in another block, and all the people that have the exact same email in another block. So at the end, what happens, instead of going for all the possible pairs under the sun, we have a series of blocks that popped up from token blocking and from standard blocking that significantly limit the amount of comparisons the algorithm has to do, okay? And this saves us a lot of time. So after you have your blocks, you need to proceed and compare the pairs, okay? So we do, for each one of the different data points, like full name, birth year, and so on and so forth, and we have around 20 right now, we do either fuzzy matching or exact matching. So fuzzy matching is like you're using some kind of model to tell you how similar they are, okay? And this is the NLP application. So let's say for the names, we apply fuzzy matching. The way to do it is you take two strings, you vectorize it, okay? Which means you turn the words into a vector. This is pretty standard procedure. You can do it with a lot of different ways. We use transformers that were designed for entity resolution. Our transformers are a version of BERT, of the BERT language model that we found from Hugging Face, and we adjusted them on some of our datasets, and they give us some similarity metric. In this example, it's like cosine similarity. And then we have exact matching, let's say for things like emails or for things like especially tax numbers and stuff like that. So the end result is you're gonna have a pair with, I don't know, 20 similarity values. And then we feed that into a classifier, into a simple classifier we built, and it returns to you an answer. This is the same entity or this is a different entity. And of course, we took the ML route for the comparison, because you know what, tax number is probably way more important than your name, okay? Like if two people have the same tax number, they're probably the same person. So the idea is the algorithm in the matching creates this person, say this and this person are the same. Finally, once you have all your thousands of pairs, you need to merge them all together into clusters, okay? And the idea is to identify Georgios. He popped up 20 different times into the data set. Now we merge him into one, and now we can actually study him to see if he's a fraudulent actor. These are some predetermined algorithms. We don't build them. Connected component center clustering and merge center clustering. We found them in the literature. I'm going to present the simplest one, the connected components, which is probably the worst one because it creates these big clusters. So this is just an example. Each one of these 7 are entries, okay, of some entity. And each line means that through blocking, these pairs were connected with each other, okay? Green line says that the matching algorithm says this is the exact same person. The red line said, nope, they're not related. What the connected components algorithm does is, because number 1 was proven to be the same person with number 2 and number 2 with number 7, it ends up to put all of them into one cluster. But this, as you can understand, creates some problems because sometimes just a single connection can merge two completely different people. That's why this algorithm is not what we prioritized, but I have it here for the presentation because it's easier for the people to understand. So finally, what the example will look like, something like this. Okay, so you can see the algorithm put all the variations of my name in predicted entity 1, except for number 2, because this guy there, even though he had similar last name with me, was born in 78, I had a completely different email. Okay, so this is pretty much our tool. And with that, I will say that we have launched the tool a month ago. The team is using it. We're hoping they're gonna get a big ads and find some bad guys. The next step for the next versions of the tool is we want to make the tool work with photographs, okay? Because a lot of our claims come after big catastrophic events, and there are vendors there that take a real photograph and send it back to the company. We want to be able to apply computer vision and see if indeed the damages claimed are in place, okay? This is still gonna be an indicator. We ain't gonna prove anything, but it's gonna be an additional level of potentially fraudulent claims. We want to build we're actually building a RAG model right now because these investigators are given now a specific capability to to study these claims, we want them to be able to interact with natural language and ask questions like, please give me all the claims that have a fraud score of 5 or more, and these bad actors are involved. And the tool should return this. So this is our goal right now. And finally, more advanced fraud metrics. At the moment, the banking sector is what's on the forefront of fraud detection. They are the ones that have the fancy algorithms. As you can see, the algorithms we used are a bit basic, but we want to incorporate these stronger and more complex fraud metrics in the future. So thank you very much. Crime don't pay, so please don't do fraud. I'll find you. Anyone has any questions, please, not hard to answer, because I might not be able to answer.
Yeah, do you take like external data when you put it in, or is it all mostly from what you already get from customers? So like, would you take the data from a customer company's house, for example, in the UK, CRO in Ireland, if they like match up that this person, the same director of both companies, getting fraud there, or?
Yeah, so we are accessing public archives in the US for. US is a strange place. Each state has its own public archives of all the companies and tax numbers. So we have web scrapers that take the data from there, if that's the question. Yeah. But apart from that, everything else is internal. We just get what is public info, but we don't, I don't know, scan social media or whatever to try to find some crazy connection.
So I'm just scraping, is that you have a step function that takes in data every night?
Yes. Yes.
And then, that's what when you say you're dealing with addresses, do you have any like tools to deal with obfuscation? Because sometimes like say a building could have 2 doors and different addresses.
True. We the company actually already has built this capability. They're using a vendor, so we're taking the data from them. We didn't have to build our own capability, so we trust the company's data on that. Yeah.
Yeah, that is the only source of information that you connect with the database in the US and get the information of the actors, or any other way, any other means you will get the information for each of the actors.
Any other means other than the customer sending us the data?
Yeah. No, other than the data present in the US to analyze whether he's a fraudulent actor or he's a genuine actor. Any other way you would like to, you will be communicating, or you get the information from for a particular customer or actor?
To be honest, the tool right now, as it is, uses the company's data. Okay, so we didn't actively went out of the way to get more data. Okay, so in this version 1, we just leverage all the data already in place, put them in our algorithms, and flag them. In the future, maybe yes. Okay, as I said, the aerial photography, for instance, we might suggest extra data or along these lines, but at the moment it's strictly either public records for things like tax numbers of public companies, or then it's internal company data.
Yeah. So the next question is, so I could see it's a wealth insurance that you are going to support with your tool, right?
Yes.
One, is there any other type of insurance do you cover?
No, actually no. Actually, this is the client, and the source code is them now. This is theirs, so we cannot sell it to anybody else. So we build it for them. They use it. They are a sole client right now in this project.
Okay. One last question. Once you get the information about a particular actor,
yes,
how much time do you need to come up with the information, whether it's a fraudulent claim or it's a genuine claim?
Because this thing runs overnight.
Yeah.
The whole thing runs in around like 30 minutes, every new claim or whatever. But we don't really care because it happens at midnight in the US. Nobody's working at that time. So when they log in early in the morning, everything is there. So the data are not that much. And maybe we didn't even try to optimize the procedure that much, because we just need it updated once a day and that's it.
Okay, that involves all that clusters, different type of
Everything,
clusters.
everything. Yeah.
Makes sense. Thank you so much.
Thank you very much.
Thank you very much for a very interesting presentation. So my question is about your automated roles or role automation. So when it comes to, let's say, detecting abnormalities, there is always a set of rule that we try to implement and teach our system to perform. There is a thing that once when we deal with people, once they figure out what the rules are, they can play them and navigate them. So my question is about when you were testing the tool, did you try to kind of fraud your own system and see if your automated rules would stand someone trying to play with the system and existing rules? Does that make sense? It's sort of like not technical hacking, like when you hire ethical hacker to hack the system, but doing social hacking to see if someone can bypass the rules that you use to detect the fraud.
Yeah, that's a nice question. The thing is, we actually just focus on claims. So people who are involved somehow, they need to be either customers of this specific company that they have insured the property and they're making a claim, or there must be people who worked on the claim. So I think the people who really need to focus on this social aspect are the team investigating the fraud and using the tool. And maybe if they see that the tool at the moment is missing a lot of clues about potential fraudulent claims, come back to us so we can translate it into software. But when it comes to me personally, I don't have a lot of experience on how fraud is actually contacted. I just built software, so this was the best we could do according to what they described as the day-to-day. Maybe version 2, yeah, we add the social aspect on this, and who knows, maybe it becomes a little bit better. Yeah. Are we good? Thank you very much, guys. Appreciate it.